Here we're looking at combining like terms and the distributive property in context. So a little bit of review of combining like terms. We have to have the same terms in in order to combine them. So we have 4m and negative 8m. So we can combine those. However, when we see m squared, we cannot combine that. Let's say we call m money and I substitute $20 in. So 20 times 4 is 80. But then 20 squared is 400, and then we're multiplying it by the 3. So it's going to be different. And then the last, we have the 6 and the 2 2/3. So I'm going to write the highest exponent first, and this will come a little bit later. I'm going to have the 4m plus minus the 8m. Cross those out. And then the last, I'm going to have the constants. So that's 6 and 2 2/3. And I just write it like this to keep it separate. So I have negative 3m squared. Then I have 4, negative 8. Both of them are m. So I have negative 4m. And then I have 6 and adding 2 2/3. So I know that's 8 and 2/3. So we're going to review all of the vocabulary with it as well. So the whole thing is called an expression, does not have an equal sign. The next are the variables. They're m in this situation, but notice one of them has an m squared. The coefficient is the number in front of the variable, which means what is multiplied by m. And then the constants are 6 and 2 2/3, and that's why we combine them as well. So the like terms, 4m, negative 8m, and 6 and 2 2/3. We don't have anything to combine with negative 3m squared, so we just have to rewrite that. Now we're going to look at the distributive property with area models. So most of us that are older learn just by doing the distributive property, and we'll look at that in a second. But conceptually, we need to understand what the distributive property is doing, and that comes in area models. So we're going to do the length times the width of this rectangle. Well, the first rectangle, we're going to do them separate. The first rectangle is 3 times a, which is 3a. The second rectangle is 3 times 5. Well, just going to erase that because that is hard to figure out what's going on. So we're going to do 3 times 5. So much better writing, which is 15. Now, we want the total, the larger rectangle, so we have to add those together. So that is 3a plus 15. Now, just like when you have addition of 6 plus 2, it equals 8, but so does 2 plus 6. That's called the commutative property. So I can change the order and also have 15 plus 3a. The next way we're going to do it is going to be the distributive property way. So we're going to do length times the whole width of this larger rectangle. So to do that, we're going to do plus, that's a crazy plus. We're going to do 3 times the whole thing of 8 plus 5. So to double check it, 3 times a is 3a. 3 times 5 is 15. And we see that from before. So 3 times parentheses a plus 15 is also correct. Here we're looking at a garden that we're going to plant. The class has a fenced-in rectangular section of the lawn where they can plant the garden. We have to read very carefully in context. Write and simplify an expression to represent the perimeter of the lawn. So we're looking at perimeter, learning my pen. We're looking at the perimeter of the lawn. So we know that in a rectangle, the opposite sides are congruent. So opposite of 12 is 12. Opposite of 3/4 x plus 8 is 3/4 x plus 8. So we have 2 of the 12s plus 2 of the 3/4 x plus 8. All right, so we know that a whole number is written over 1 in order to multiply fractions. So I'm going to come up to the top and write 2 times 12, which is 24. Then I have 2 times 3, which is 6. 1 times 4, which is 4. So that's 6 fours. Many of you may want to reduce this or put it in a calculator, but you divide both by 2, and so then we get 3/2 x for that one. All right, and then the last thing is 2 times 8. So we did the first one already. We do 2 times 8 now, which is 16. So here we have 2 constants and 1 variable. So the answer here is going to be 3/2 x plus 40. So I'll go ahead and erase that other because it looks confusing here. All right, so that is the perimeter formula. So now we're looking at B. B is going to be the area. So the area model is length times width. So we already have it as 12 times 3/4 x plus 8. 12 times 3/4, we're going to write up at the top as 36/4 x. And then 12 times 8 is going to be 96. Well, if I divide 36 by 4, I'm going to get 9x plus 96 for the area. The last part, we're doing the substitution. So we're now saying that, okay, x is 8. X could be any number to create a similar rectangle that is proportional. But this instance, we're going to substitute for 8. So we're going to take the perimeter formula, and wherever we have x, we're going to put 8. And we know that's 8 over 1 plus 40. So the perimeter is 24 over 2, which I know is 12 plus 40. So the perimeter is going to equal to 52. And this is just 52 feet for perimeter. Erase that so it'll be a little cleaner. Well, all right, so now we're going to do the area. So we're doing the same thing as before. We're substituting in 8 for the equation. So the area was our 9x plus 96. Instead of the x, we're going to substitute in 8. So 9 times 8 is 72 plus 96, and that's going to equal 168. So there's 168 feet. We know the area is squared. So the area is 168 feet, and the perimeter is 50.